Hi everyone, Dr. Zach again. So some of you guys complained that I wasn't in the videos earlier in the semester, so now you're seeing me all the time. Yay! I guess I'm doing good enough to be kept around for these, or just Dr. Burks is claiming seniority and refusing to do these. Whichever one, who knows. In any case, today's lab is about pH, which you should have covered in lecture already. And the pH tells us whether or not some chemical is acidic or basic. And this comes in handy in everyday life where you might need to know if some food you're eating or something you're drinking is acidic or basic. And so to determine pH ranges, one thing that you could use is an indicator solution. So with that solution, when you add it to a solution, it will be a different color depending on whether the solution's acidic or basic. And remember, when something goes from an acid to a base, it loses a proton. And so the different indicators tell you the pH range where that chemical will lose its proton. And some of you might wonder, why would you even use an indicator solution when we have things like litmus paper or pH paper? And really, it comes down to sometimes cost or just availability. You might not have pH paper lying around. If you're using litmus paper, it doesn't give you a range of pHs, it just tells you acids or bases. And indicator solutions are also pretty easy to make at home. Like if you boil red cabbage, you have a really good pH indicator to use at home if you ever want to measure anything. So we can talk about indicators a little and how we're going to use them to narrow down the range of pH if we don't know it for a certain solution. And so there is a table in your lab manual, and so it's this fun little guy. And so we have all the indicators that we're using. So there's a column here and a column there. And it tells you the range that pH covers as it goes from an acid to base, and tells you what the color transitions will be for that particular indicator, depending on what kind of pH it is. And so to give you a better example of how to read this, because I know it can be a little confusing, we can have our blown up version of the table on the board, like magic. So these are just like the first two indicators on the table. And so say we want to measure something using methyl violet, so we have our solution wall plate that you'll see. We drop in a couple of drops of methyl violet, and with methyl violet, if the pH is below 0.5, it's acidic, of course, this is an acidic indicator. If the pH is below 0.5, the solution will be yellow. On the other hand, if the pH is above 2, the solution will be blue. Now you might be thinking, what if it's in between? What if it's between 0.5 and 2? In which case you're going to get a greenish color out of this. And so you don't really know what the actual value is within this range. And so you can go to another indicator to try to narrow it down. For instance, if you have thymol blue, which works in the pH range 1.2 to 2.8, you can see that this kind of covers the same range, but it starts a little higher in pH. And so now if you take your solution and you add your thymol blue, and it's red, for instance, you know that your pH has to be between 0.5 and 1.2. If it's, orange or yellow, it's going to be higher than 1.2. Or if it's yellow, it's going to be higher than 2.8. So you can kind of narrow things down using multiple indicators, and that's what you're going to be doing in this lab.